Hello everyone, my name is Timothy Muriwa Joseph. So in this video, you are going to learn about velocity time graph. And our lesson objectives include draw a velocity time graph. So this is what you're going to learn. You're going to learn how to draw a velocity time graph. Secondly, you're going to learn how to calculate acceleration from a velocity time graph. Number 3, you're going to learn how to determine retardation from a velocity time graph. And the last, which is very important, is how to calculate distance from a velocity time graph. So these are the things you're going to learn in this video. So I want to beg you to watch the video to the end for you to gain the whole understanding of velocity time graph. Let's take a look at this graph. This is a typical example of velocity time graph, which means velocity is plotted against time taken. And then here we have our constant acceleration here. And then we have the acceleration, which is 0 here because our velocity is constant. So whenever velocity is constant, the acceleration is going to be 0. And this is positive acceleration. This line represents positive acceleration. And this one that goes down to the x-axis here, which is the time, it is the negative acceleration. Sometimes it is called retardation or deceleration. So, and then anytime this line crosses this x-axis or the horizontal line or the time axis, it means the object is changing direction. Okay, so let's look at example how to do this by ourselves. We've got a first example here. A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. It continues with uniform velocity for a further 20 seconds and then decelerates so that it stops in 20 seconds. Calculate the acceleration, B, deceleration, and C, distance traveled. Okay, so we need to first plot a graph for this entire journey. So I'm going to make a rough sketch of the graph and then we transfer it onto this graph sheets. Are you ready? Okay. So from this question, a motorcycle accelerates from rest for 10 seconds up to a velocity of 20 seconds. So firstly, we're going to draw our axis. So let's say this is just a rough sketch. So don't need to be precise. Rough sketch. Okay, so this is our velocity axis, so which is the y-axis, and then we usually plot the velocity against time in velocity time graph. So let's remember to put the units because it attracts marks in exams. So, and then we draw the horizontal axis or x-axis, which is going to be for the time taken. So we put t here and then we write the symbol, or sorry, the unit. So starting from origin, then let's go back to the question again. A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 seconds, which is the maximum velocity. Okay, so let's say we are taking maybe 2 centimeters to 10 units. Okay, so this is going to be 10, and then here too, maybe 2 centimeters to represent 10 units if you want it. So this is just a rough sketch, so we're not going to be accurate here. So this is 10 and then this is 20. Okay, so for 10 seconds to reach the velocity of 20 meters per second. So let's use a broken line to trace from 10 seconds to 20 meters per second here. And then so we're going to have the movements, the motion like this. So this is the first motion. It continues with uniform velocity for a further 20 seconds. Yes, uniform velocity for a further 20 seconds. So which means when you add 20 to this 10, you're going to have 30. So it means here is going to be 20, and then here we should have our 30. So which means we should have 30, and then let's use broken line again to take it up. Okay, 20. So this is where we have the uniform velocity. Yeah. Look at the question again. A motorcycle accelerates from rest for 10 seconds. We've gotten it here, up to a velocity of 20 meters per second. And then it continues with uniform velocity, and this is our uniform velocity for a further 20 seconds. So here, and then decelerates so that it stops in 20 seconds. Again, it decelerates. Okay, 20 seconds, 20 plus 30 seconds, we've got 50, so it's going to stop at 50. So here it's going to be 40, and then here is 50 seconds. Then it decelerates this way. So this is the deceleration. You can see it. So we can label it. So we call here A. This point is B, and then this point is C, and then here is D, then you call here E for the purpose of calculation. Yeah, if you like, you can use any other letter alphabetically. If you can P, Q, R, S, T, V, if you like, still okay, but I'm just using the simplest ones here. Okay, so this is how the graph is going to look like. This is a velocity time graph. So we can now transfer it onto a clean sheet like this one. So we should have something like this. Let me use black. So we've got this, and our time axis. Okay, so let's put the arrow head. Oh, look at my arrow. Okay, so this is time, and the unit is s. Let's write it. This is velocity, the unit is meter per second. Let's try to write it. Okay, right. I'm sure you understand what I've explained here. Or do I still need to explain it again? So I think it is clear. So we just transfer it now. So let's label it. So here is 0. We've got 10 here. And here is going to be 20. Our maximum velocity. So 10, 20, 30, 40, then 50. So let's write the time. We have 10, 20, 30, 40, and then we have 50. Okay, so from the question, which I've already explained, it's accelerate from rest for 10 seconds up to velocity of 20 meter per second. These are velocity here. So we can also use broken line to represent this. So let's use broken line. So let's trace from 10 to 20 meter per second. Okay, here, and then we draw the arrow. Okay, we draw the motion from the origin. Okay, this is it. And then it continues with uniform velocity for a further 20 seconds, which means 20 plus the first 10 is 30. So we have from between here to this point. So you can also use broken line to mark that. So let's use broken line for it again for clarification. So, so that is where we have our uniform velocity or constant velocity, which for the motorcycle, and then decelerates to so that it stops in 20 seconds. So, which is 50. I've explained that here. So, shouldn't have problem with that. So, let's just draw the line, not to waste more time. Let's draw the line for the motion. So, we should have something like this. Okay, good job. Then we can now label it. So we call this point A. This is A, B. We're doing this for the purpose of calculation. This is our C, D. Don't forget you can choose to use any letter of your choice, but I'm using the simplest ones. Okay, so you're going to have something like this. So this is a typical velocity time graph showing the acceleration, showing also the uniform velocity, and then deceleration. So we've got positive acceleration here from OA, O to A, positive acceleration, and then we have a velocity which is constant, and then which means the acceleration is going to be zero here. That's between A and B, and then we have a deceleration or retardation, if you want to call it retardation. Okay, so for you to calculate the total distance for the motion, okay, I think let's now begin our calculation. So first question is to calculate acceleration. So we need to calculate acceleration for this journey. Okay, so let me get rid of this. I want to go. Oh, my eraser is so small. Okay, first question, acceleration. So acceleration along OA, that's what we're going to calculate. The acceleration along OA from here to here. So acceleration along OA. Okay, let me write it separately. OA. Okay. So acceleration along OA is given as velocity change divided by the time taken. That is change in velocity divided by the time taken, which is going to give us the gradient of OA. So all we need to do here is to calculate the gradient of OA. And for us to calculate the gradient of OA, which I said that it is change in velocity divided by the change in time taken. So that is going to give us the acceleration. So that's our gradient OA, or the slope, if you want to call it slope or gradient. So gradient is going to be equal to change in velocity, okay, divided by change in time taken. This delta time taken, which is change in velocity is OA, sorry, AE rather, divided by OE, okay? That is this point to this point. So this point is what we have here, this A. This is A, and then when you trace it to this velocity axis or y-axis, you have 20 here. And then when you go down, so here you've got E, and when you trace it to the y-axis, which is the velocity, you have 0, and then that means 20 minus 0, you are going to have 20. Okay, so let me write this clearly. So it's going to be AE divided by OE. Okay, so then we're going to have our gradients as AE. I've explained this, so we have 20 minus 0, and then you've got 20 here. And then OE, which is this on the x-axis, which is 10. So divided by this, 10, yeah, divided by 10. So we divide by 10, and then when we do our division, we should have 2. And then we put the unit 2 meter per second square. This is the acceleration along OA. So this is the acceleration for the journey. Yeah, acceleration A for the journey. And then the next question is to calculate the deceleration. Deceleration happens along BC. Deceleration happens along BC, and it's also the gradient of BC. So which I've already explained. A gradient is change in velocity divided by the time taken here. But this deceleration, the answer is going to be a negative acceleration because it decelerates. So it's going to be negative. So let's try to find it. So it's going to be along BC, which means we're taking the gradient of BC, and then our deceleration will be, so B, deceleration is going to be BD divided by DC. So let me write it also for clarification. Deceleration happens along BC. Okay, so and then which is change in the velocity divided by the time taken. So we are going to have BD divided by BC. So which is equal to, that's, you are taking the gradient again, BD divided by DC. Okay, so what do we have? BD, what do we have here? Again, when you go this way, you have 20, and when you go this way, you have 0. I've already explained this, so how to take your gradients, which means you have 20, and then you take the difference, DC, from 30 to 50. The difference should have minus 20. Then this cancel this out. We have minus 1 meter per second square. So this is the deceleration. This is how to calculate the deceleration. So basically, you are taking the gradient of the motion. When you have to calculate the acceleration from a velocity time graph, we take the gradient of the motion, the first motion along OA here. If you have a line like this, and then the deceleration, you take the gradient also as well. And gradient is just change in velocity divided by change in the time taken for the journey. Okay, so let's calculate the last question, which is distance traveled. Distance traveled. So in this case, distance traveled is the entire area in this graph, the entire area under this shape, or in this shape rather. So, and if you look at this shape OABC, it is the shape of a trapezium. Shape of a trapezium. So all we need to do is to apply the formula of a trapezium to calculate the area of this shape, and that is going to give us the total distance traveled by the motorcycle. I think this is just straightforward. If you use the formula of a trapezium, some people can decide to divide this shape into three. As you can see, we have OAE, and then we have ABDE, and then we have BDCE, and then they calculate this OAE as a triangle, the area of triangle, then they plus the area of this rectangle, and then plus the area of this triangle BCD. But I think that is just a waste of time. But if that is what you understand, I think feel free to do that. But the shortest route is to look at the shape you have. Since it is a trapezium, then you just applied the formula of a trapezium to calculate the area, and then that will give you the distance traveled. So, we have point C. We all know that area of a trapezium is given as, okay, let me just write it first. Total distance traveled. I think I've explained it, so we don't have more space here. So it's the C is going to be distance travel is the area of the trapezium that you have. Distance travel, total distance traveled. Okay. So total distance travel is the area of the trapezium, but if the question says distance travel along OA, so it's just going to be the area of this triangle OAE. Okay. All right. So total distance travel is, we are going to apply the area of trapezium, which is equal to area of trapezium. So enough of writing. I think it is clear. So let's just write out the area of trapezium. Who can remind me of trapezium? So area of trapezium is given now. It's 1 over 2 open bracket, the sum of the two parallel sides, which is AB plus OC. AB plus OC here. Okay. So we have AB plus OC, close the bracket, multiplied by the height, and the height is just AE. AE. Height is AE. So we write AE. So this is what you need for this calculation. Okay. So let's try to apply it. So we have 1 over 2 brackets AB. What is AB? AB is basically what? Yes, look at what do we have from here to here. This is 10 and this is 20. So AB is 20 plus OC. Of course, from 0 here to C. 0 to C, which is 50. So we write 50. Multiply by AE, which is our height, and our height is the maximum velocity, which is 20. And then we calculate. So we have, goodness. So we have 1 over 2. So this is 70 times 20. So what do we have? 70 times 20. So we should have 1,400. Okay, it's brackets. So these two we cancel these two, and then we have 7, and then we're going to have something like this, 700. 700. So this is a bracket. 700. We calculated distance, which is the unit is meter. So don't forget, units are very important in science or physics. Okay, so the total distance travel is just 700 meters. So this is how to calculate total distance travel in a velocity time graph. Okay, so I think you have learned how to calculate acceleration from a velocity time graph. You have also learned how to calculate deceleration, and then how also to calculate distance traveled, and most importantly, how to interpret velocity time graph, and even how to plot the graph by yourself. So these are all the things that I've covered in this lesson. Please do like this video. If you have any questions, please write in the comment box. I'm going to respond to your question. Like the video, share it, and also follow my page for more updates. Thank you for taking your time to watch. Goodbye. See you again.